So 3.7 is all about factoring polynomials, but the big thing in this one is something called the factor theorem and the remainder theorem. And the words are much bigger than the actual deal. These sound like, oh, it's a big, huge deal, but in reality, we've already been sort of doing it. And when you hear the results of this, you'll kind of go, what? Why the complicated name? The remainder theorem essentially says that if we don't get, by the way, here's x minus 4, x minus 2, and I'm just showing you the expansion. This is it in standard form, and this is it in factored form. Whenever we plug in a number into this, it's quite clear that this are the x-intercepts, right? The x-intercepts quite clearly are 4, 0. I'm just going to get rid of everything. 4, 0. 2, 0. And minus 2, 0. Very clearly. The only time we're going to get 0 as a result is if we plug in these x numbers. Nothing else will produce a 0. These are the only x-intercepts, which means any other number that we plug into this equation will produce something that's not a 0 or a remainder. The remainder theory is really silly. So it essentially says that if I plug in a number here, these are the roots of those x-intercepts. If I plug in the number into the equation, I'm going to get a result of 0, which means if I plug in the root, I'm going to find out the factors accidentally. And that seems like so common sense that you're going to say, why did they call it a theorem? And this is essentially the theorem. When you have x minus any number as a factor, the f of a, in other words, when you put the actual root into the equation, you'll get a result of 0. And that's the factor theorem, which means that if you just start plugging numbers into the equation and you find one, let's say you plug 4 in and you get a 0 out of the equation, that means x minus 4 is indeed a factor. And it just means that you can plug in numbers to slowly figure out how to factor it when it's tough to figure out the factoring. For instance, if you were to look at this, you'd notice a pattern of 4, 4, and you'd probably figure out that there's something like x minus 2 in there, x plus 2. The other thing this chapter does is how to deduce the factors, and for that you would look at the number in front here and the number at the end. Well, the only way to produce a 16 at the end is 1 times 16, 2 times 8, 4 times 4, and that's it. You can also have every minus version of that, like minus, minus, minus. And that's 16, since there's nothing in front of the x cubed, gives you an immediate indication that we could have these as factors, x minus 1, x minus 16, or x plus 1, and x plus or minus 16. It also could be x plus or minus 2, and x plus or minus 8, and x plus or minus 4. And we got all of those from these factors. Now, obviously, if I'm going to test it out in this equation, what's the easiest one of all of these to use? Well, it's obviously 1 and minus 1, and then 2 and minus 2. I'm not going to jump straight to the 16, because plugging 16 into this equation will create monstrous numbers. So I'm going to immediately start with 1 and then 2. So as I'm trying to figure out what possible, if I didn't see the pattern, for instance, I could right away try grouping. And this chapter covers all sorts of methods of trying to figure out some of the roots. But one of the first things you should do is plug in 1 into all of these wherever you see x. So 1 cubed is 1, x squared is 1, so minus 4 plus 16. That does not come up to 0. So 1 plus 1, or x minus 1, is not a factor. And we already know the factors over here. And when we plug into minus 1, we get a similar result. We get minus 1, minus 4, plus 16. That does not add up to 0. So x plus 1 is not a factor. And when we jump to 2, that's when we immediately get some information. So 2 here is 8 minus 16 minus 8. So these cancel out. Plus 16. So these cancel out. Boom. We immediately found out 0 when 2 is put in for x, which means x minus 2 is a factor. And that's all this theorem goes about. If it's not a factor, whatever the remainder is, let's say I were to plug in 3 into this, and let's say I get, I don't know what I would get out of it, but let's say I get a 56. That actually means that 3 comma 56 is a spot on this graph, right? That's all the remainder means. So if I was to factor in x minus 3 and do long division into this equation, and I end up with a remainder of 56, it means that 3 comma 56 is a point. And that's all the remainder theorem and factor theorem goes on about. It's saying you can figure out various ways to factor this using those theorems. But what this book chapter also deals with is various methods to try to figure out how to factor it. So, so here they go with the remainder theorem. Where the polynomial f of x is divided by x minus a, the remainder is equal to f of a. So that's all they're saying, is that you will find a dot on there that is on the graph. We kind of figured that out with the last problem. And selecting tools and strategy. So here they're asking us to factor this completely, and they're looking at 24 here, and they're saying, okay, well, all the possible factors of 24 are these. We're going to start with the easiest ones, plus 1. And then they're using graph calculators in there. You should also get used to, possibly if you're in university, you might need a graphing calculator, so learn how to use one. They don't let you bring computers in. For us, we're just going to use Desmos. And then it just lets you figure out, oh, when I plug 1 in, x minus 1 is not a factor. When I plug minus 1 in, I get a remainder of 0. So that means that, here they do for x2, and they do x minus 2, and they come up with 0. So right away they realize that if f minus 2 comes out with a remainder 0, x plus 2 is a factor. Then they do synthetic division, and they come out with their trinomial, and then they factor the trinomial, or the binomial, sorry, the quadratic, and then they factor that normally. And they're just essentially, because you can't really figure out a factor for a cubic or quartic or any bigger polynomial unless you break it down to a parabola and some sort of factor. And they're just teaching you how to figure it out. So it's essentially learning how to factor things that are bigger than a parabola. Then they teach you how to make sure to look out for common numbers. So in this case, factoring out 2x is a lot easier. And then you're left with a much simpler cubic to factor instead of a quartic, which is what we started with. Then they go through the remainder theory to figure out that x minus 1 is a factor. By plugging in 1 into the equation, they get 0. That way they know x minus 1 is a factor. They do synthetic division. They're able to break it down into a parabola and then use normal factoring for the parabola. Then they're able to graph it. They're able to figure out it has 4 x-intercepts here. They can map it in, and you can even figure out that one of the that'll only cross the y-intercept at 0, 0, because you see that there's no number down here, so you know it only goes through the y-intercept at 0, 0, and you have a nice graph. And you also know that the behavior pattern of a quartic starts in quadrant 2 and ends in quadrant 1. Then they remind you how to factor by grouping. When you see common numbers, you can divide them up in their commonality and hope that when you factor something out of both of them, you're left with a common factor in each, and therefore come up with a common factor. This one can then have x removed out of it, and you're left with x squared plus 2, which gives you all the roots, actually. This one's going to be equal to plus or minus square root of 2. This one's going to be equal to 6, and this one's equal to 0. And you're able to graph it. And then they're asking you to solve situations where you don't know the m and the x, but you do know some of the information from the remainders, and that some sort of things are a factor. Well, if 2 is a factor, you know that the whole thing is going to come out as a 0. And since they give you two solutions with two missing variables, you're able to solve it. So the first one, they do it with a remainder of 12 of x minus 1, and they just plug it in to the equation. They come as far as they can, and they get an equation for m and n. Then they do it for the other, knowing that 2 is a factor that has a remainder of 0, and they plug it in knowing that it must equal 0, and they get another equation for m and n. And then you're allowed, since you have m is equal to this, you're allowed to put that into this equation here and solve it. So a big hint that I always want to remind students is this. If you are missing two variables, you need two separate equations. Three variables, three separate equations. And so the more values of x, y that you have from a graph, the more you're able to solve these things. Four variables, of course, four separate equations. So when you're missing two things in an equation, know that your teacher wants you to somehow come up with two equations. When you're missing one variable in an equation, know that you only need to come up with one solution. And then they come up with n and m, and they put it into the graph to test if that's true. Then they summarize. And now remember, the summary is always here. You can always jump straight to the summary, and if you don't understand it, then go back and know that all their examples will be reflected into the equation. Looking at the example I gave you here, if I were to group these two here, I could take x squared out of both of them. I'm left with x minus 4. And if I were to group these two out of it, I could take minus 4 out of both of them, and I'm left with x minus 4. And right away, I've successfully factored it by grouping. I've gotten to this stage. So that means I've got x squared minus 4 as one factor, and x minus 4 as another. I immediately will notice that that's a difference of two squares, which means it's x plus 2, and x minus 2, and x minus 4. So that's a good example of being able to factor by grouping, especially when you see a common pattern here. And I'm able to get over there. However, I could do the remainder theory using 1, 2, and discover that indeed 2n minus 2 plus n minus 2 come out with 0 in here, which would instantly tell me these two factors. And then it would be very easy to figure out the third. So let's go on. Let's do some of the questions. They let you warm up first to make sure you understand the basic concepts. Check your understanding. Since this cubic is determine the remainder of f of x when we're dividing by the both polynomials without dividing. So they're essentially asking you to use the remainder theorem. You might say, I don't quite get what the point of this is, but it leads to other things. Okay, it leads to other things. So let's look at it. So the first thing to do is figure out the root that they're looking for. Well, the root here is plus 2. What's the root here? Minus 4. What's the root here? Plus 1. So we're essentially going to plug each of those into the equation and figure out the remainder. Okay. Now, personally, I could do that, but I'm just going to have Desmos do it instead. Pardon me. X to 4 plus 5x to 3 plus 3x squared plus minus 7x. And what was the last number? Plus 10. Okay, and then right away, if I can just plug this in, and it will give me my answer. But you can do it the long way. So what they actually want you to do, and you should do, because on a test you're going to have to do, is plug this plus 2 into the equation. You have to do 2 to the 4, which is 16, I think. You have to do 2 to the 3, which is 8 times 5, so you got to add plus 40. Then you got to do 2 squared, which is 4 times 3, so you got to add 12. And then you've got 2 times 7 minus 7 times plus 2 is minus 14. And then you got to add 10. So this last part, minus 14 plus 10, is just simply minus 4. When I add all this, I get 56, 58, 68, minus 4, 64, which is what I got here, so that I know when I plug 2 in, I get 64. Since the remainder is 64 when I plug 2 in, I discover that at 2, 64 will be a point on this graph. So if I go here, and I go to 2, oops, let's see where 2 is. Oh yeah, of course 2 is going to be way up here. That's 64. So you go way up on this graph and you plug right there, you discover a point 2, 64. So that means the remainder theorem, even though it's very obvious, you can say, well, of course, you plug 2 in and you got 64. But all it means, if I were to do long division of this whole thing, if I was to take x minus 2 and do long division into this whole thing, I'm going to be left with a remainder of 64, which immediately tells you 2, 64 is a point on the graph. It seems silly, but that's what they're getting at. Now, if I take minus 4 in here, you can see how annoying the equation gets. But they essentially want you to put minus 4 in there, come up with it to the power 4, so it's going to be positive. So you're going to get 256, I think. So 256. The next one's going to be negative, so it's going to be 5 times 64. So you can see how annoying it is. So minus 320. Then you're going to get minus 4 squared, 16 times 3. So 16 squared times 3 is 48. And then you're going to get minus 7 times minus 4, which is plus 28. And then plus 10. And then you can focus on adding these if you want. 38 plus 48 is 86. 86 plus this is going to be 92, 142, 342. 342 minus 320 is 22. Now, you can see how many mistakes I could have made. So I will just make sure that f minus 4 is indeed that. And I get plus 22. And that's what I had. So that means that the remainder for 4 is going to be 22. 1's a lot easier. When I plug in 1, I get 1 plus 5 plus 3, so that's 9, minus 7, so that's 2, plus 10, 12. So that's going to be 12. So if I go to my book, and go to the answers, I can see the remainders here. Oh. Oh, I got the wrong lesson in here. So I've got to go back into the answers and get the right answers later on. But I've got the wrong answers. I'm going to maybe go collect them very quickly. Chapter 3. We're on to 3.6, not 3.5. So I'm going to just take a quick snapshot, and hopefully that's big enough. And just put it there. Try that again, sorry. I'm just going to take a snapshot of all these answers and put them right there. Don't know why it does that. I think it's because I'm not... There we go, got it. Now that might not be big enough. But so be it. I'll just get rid of 3.7. And I'll do that. A little bit blurry. But there they are down below. There's the last lesson. I'll just get rid of that. There they are down below. 64, 22, and 12. Great. Let's continue. Next question. Are there any binomials in part A, factors of f of x? Are there any binomials? No, they're not, because none of the remainders were 0. If they came out as a remainder of 0, there would be factors. Instead, they're way up and down the graph. Which the following functions are divisible by x minus 1? They want you to use the factor theorem here, not synthetic division. They essentially want you to plug in 1 into each equation And if you get a remainder of 0, it is indeed a factor. So if I plug in 1 here, I get 1 minus 15 plus 2 plus 12 minus 10. So 12 minus 10 is 2. 2 plus 2 is 4. 4 plus 1 is 5. Minus 15 is minus 10. So that means the remainder is minus 10 at when x is 1, which is what they ask us to do when they give us the root like this. You're putting in when they give you the factor, rather, you're putting in the root to the equation. So we discover remainder is not 0, therefore that one is not a factor. Go to the next one. So we're plugging in the root of 1, and we get 1s are easy because you just essentially take the coefficients in front. Plus 3 minus 4. It's clearly minus 4, and minus 4 is minus 8, and the 5 plus 3 is 8, so the remainder will be 0. So that means that this is indeed one of them. Yes. Just underline it. Then you just go continue like that. You're just plugging in 1 into the equations over and over to see if they're factors. So you get 1 minus 7 plus 2 plus 9. So you can see that it's 11, minus 1 is 10, minus 7 is 3. It's not a remainder, so no. C is not, x minus 1 is not a factor in that. And this is just essentially a faster way than trying to do synthetic division. It's very clear from this one that 1 is a factor because 1 minus 1 will be 0. 1 cubed is 1. Minus 1 is 0. So yes, that is a factor. So A, B, and D, x minus 1 is a factor. And in A and C it's not. Determine all the factors of this. Okay. Oh, jumping back to, I don't have to jump back to the answers for that. That is indeed the right answer for number 2. Okay, what about this? Well, this is where we have to look at the first number in front. It's a 1. And we have to look at the last number, minus 6, which means since we know the numbers are the things at the end that create the number, we know we're dealing with 1, 6, 2, or 3. That 2 times 3 is 6, 1 times 6 is 6. And we're also dealing with their positive or their negatives because we're dealing with minus 6. Now, obviously, the easiest numbers to start with are 1 and minus 1. So we're going to do that. If I plug in 1 into this, I get 1 plus 2 minus 5 minus 6. Quite clearly, that is not 0. So plus 1 is not a factor. In other words, x minus 1 is not a factor. So you do the next one, minus 1. The easiest ones to do. With minus 1 cubed is minus 1, plus 2, plus 5, because minus 5 times minus 1 is plus 5, and then minus 6. It's clear that minus 1 plus 2 is plus 1, plus 5 is 6, minus 6 is 0. So that means minus 1 is a factor, in other words, is a root. In other words, x plus 1 is a factor. Now that I've discovered that, I can take my synthetic division and say, okay, x plus 1 is a factor, which means minus 1 is a root. I can take all these and use my tricks from synthetic division and take all the numbers that are in front of it. There's a 1, there's a 2. Because there's a 1 in front of x cubed, it was easy to figure out the factors for minus 6. And because this has no 1, only has a 1 in front of it, its synthetic division is easy to use. And you just follow the same rules of synthetic division as always. You bring down the 1, you multiply by minus 1, it goes up here. Then you add these together, you get 1, you multiply by minus 1, you get minus 1. When you multiply these together, you get plus 2, or sorry, when you add these together, you get minus 6, you multiply it by minus 1, and you get plus 6. And you can see that these last two do indeed cancel out for a remainder of 0, which means these are the leading coefficients for your quadratic. So you get 1x squared plus x minus 6, like this. So we figured out that this so far is the answer x plus 1 as a factor times this quadratic. Like that. Now the question is, can we factor this? Is there a number that multiplies out to minus 6 and adds up to plus 1, which is the number in front of x here? Yes, there is. It's plus 3 and minus 2. So that we can easily see the factors here using our factor theorem is this. So minus 2, x plus 3. And to confirm, you can always expand all of this to make sure you get back to that. So if you do it quickly here, you get x cubed plus x squared minus 6x plus x squared, so there's the plus 2x squared, plus x, so minus 6x plus 1x gives us the minus 5x, and then finally minus 6 gives us the number. So yes, expanding that does lead me back to this, so I do indeed have the correct factors. Just going into the answers in the book, we will see that x plus 1, x plus 3, x minus 2 are indeed the factors. So there you go. Moving on. So you can see how 76. You can see how factor theorem speeds up discovering the factors instead of doing synthetic division over and over again and just guessing. Then they want you to practice endlessly, obviously, and they want you to make sure, find out the remainder when we have x plus 2 as a factor. State the remainder where x plus 2 is divided into each polynomial. So I don't know if they want you to do long division. It doesn't make sense. So I'm just going to use factor theorem. What's the root for x plus 2? It's minus 2. So if I plug in minus 2 to each equation, I'm going to get the remainder. So minus 2 for this, I get 4 minus 14. So that's minus 10, minus 9, or plus 9. So again, 4 minus 14, so minus 10, plus 9, minus 1. That's the remainder. So that means when minus 2 is x, minus 1 is y, but that's also the remainder. So minus 1 for that one. If you do a long division or synthetic division, you can also find out that's true. So looking at the numbers in front of this, I get 1, 7, and 9, and I'm factoring in a root of minus 2. So bring the 1 down, multiply by minus 2, I get minus 2. Add them together, I get 5. Multiply by minus 2, I get minus 10. Add them together, I get minus 1. I get the same remainder doing synthetic division. And I would if long division, I'd get the same remainder. So there you go. Just get rid of that. What about this next one when I put minus 2 in there? Minus 2 cubed is minus 8. Minus 8 times 6 is minus 48. Minus 2 squared is 4. 4 times 19 is 76. Minus 2 times 11 is minus 22. And minus 11. So when I add all those up, minus 22 minus 11 is minus 33. Minus 51 minus 81 plus 76 is minus 5. So that's just in my head. I might have made a mistake, but the remainder is minus 5. Then you go on to C, and you do the same thing. You're plugging in minus 2 into the power 4, which is plus 16. Yeah. And then minus 2 squared is 4, so minus 20 plus 4. This one comes out to 0, which means that x plus 2 is a factor. X plus 2 is a factor. So I could do synthetic division and figure out everything that's left. Just remember, for synthetic division, I've got to add in an x cubed here and an x, one x cubed here and an x over here. So go revise your synthetic division. It's a very useful tool to learn, period. Okay, plugging in minus 2 into here, I get positive 16 again. Positive, because it's a minus times a minus. Positive 16. Then I get minus 44 plus, or sorry, minus 20 minus 2. So minus 44 minus 20 minus 2 is minus 66 and 32. So I got 32 minus 66. So that gives me minus 34. So I'm going to say for this one, the remainder is minus 34. Might have made a mistake on that one because that was pretty rushed. Okay. And then I just do the next one, E. And I put minus 2 into the equation. Get minus 2 cubed is minus 8. Minus 2 squared is 4 times 12. 3 is plus 12. Minus 10 times minus 2 is plus 20. And then plus 6. So I get 26, 28, 38, and then minus 8 is 30. And then finally the last one, F. I do the same thing. I'm putting minus 2. Minus 2 to the power of 4 is 16 times 4, 32, 64. And then this is minus 8 times plus 12, so that's minus 96. Let's see how annoying it gets. And then you get 4 times minus 13, which is 452, minus 52. Then minus 32, 3 times minus 2 is plus 66. And then plus 18. Wow. So this one I might use a calculator, but 64 plus 66 is 130. Plus 18 is 148. And then this is pretty much subtracting 100 and then adding 4, which is subtract 100, add 4, I get 52. And then when I subtract 52, I get 0. So the remainder of this one is 0, which means that x plus 2 is a factor. And I could do long division and factor it. Let's see how we did. Now again, I was doing some of those pretty fast, so who knows. Looks like I got some of them wrong, but that's okay. So here they are here. So I got the minus 1 is correct. Minus 5 is correct. 0 is correct. Minus 34 is correct. Oh, I forget what I wrote down here. Did I write down 30? I hope I wrote down 30. Anyway, 30 is correct, and then 0 is correct. So that's good. You can see if you're how easy it is if your multiplication and addition is pretty sound. Okay, on to the next one. Determine if it is a factor or not into each of these. Now this is an unusual one. And they've made it quite difficult to use the polynomial, to use the factor theorem. Because what is the root of 2x minus 5? What is the root? The root is 5 over 2, which is the same as 2.5, which means I have to plug in 2.5 into these polynomials over and over again to get the root, or 5 over 2. I have to cube it and square it and all this other stuff. So you can see that it's quite annoying. Yeah, I could plug it in. You could also do factor theorem and, synthetic division and just remember to divide everything by 2. But obviously this whole thing's about factor theorem. So I want to notice if there's patterns. So let's see if there's some patterns first. I see that there's a strong connection here. In the first one, I can take out x squared from both. And I get 2x minus 5. And the second one, I can take out nothing, minus 1 from it, from this here. And I get 2x minus 5. So right there, I see it's x squared minus 1. So I can get x squared minus 1 times 2x minus 5. And this also can be broken down into x plus 1 and x minus 1, which means the factors of this are indeed x plus 1, x minus 1. So they just want you to practice if you can spot some factors. There we go. Now I did this by noticing a pattern here. This looks very similar to this. And I could factor out by grouping. Let's see if the others will have similar issues or if there will be a trick. So B, do I see a pattern? Yeah, I do. I think they're just making you practice your factor by grouping. The first one, again, I can take out x squared. I'm left with 3x plus 2. The next one I can take out minus 1, and I'm left with 3x plus 2, which means x squared is what I took out of this first one. X squared minus 1 is a factor, and 3x plus 2 is a factor. And this breaks down in x plus 1, x minus 1, which means 2x is not a factor. So yes for this one, no for that one. Let's continue. Ooh. Is there a pattern here? Wow. Don't think so. I think this is probably one of those situations where you have to suck it up and look at the possible factors here. And then maybe even say, well, I can figure out some other factor and hopefully get 2x minus 5 out of the results. Let's see if I can do that. Let's work with our standard 1 and 2 and see if one of those is a factor. So when it's 1 here, I get 2 minus 7 minus 13 plus 63 minus 45. So minus 45 minus 13 is minus 58 minus 64. Let's try that again because it looks close. So this is minus 20 minus 45, so minus 65 plus 63 plus 2. So that's 0. So that tells me that x minus 1 is a factor. If x minus 1 is a factor, I can do synthetic division, and just use there. So you want to write that down though somewhere. You always want to say, okay, I've discovered that x minus 1 is a factor. And how did I do that? By plugging in 1 into the equation. Then you want to put all the coefficients and make sure they're all there, and they are. And try to factor it. See if you get 2x minus 5 out of here. So you bring the 2 down, times 2. When I add it, I get minus 5. Times 1, I get minus 5. When I add it, I get minus 18. Times this, I get minus 18. When I add it, 20, 43, 45. And sure enough, I get 0. So here's my next phase. I've got 2x cubed minus 5x squared minus 18 plus 45. Right? And this last one's an x. So I got cubed and squared. So that's what happens when I factor x minus 1 out of it. The next question is, can I figure out a factor here? Can I figure out a factor here? And again, you might just start with 1, right? I can tell you right away 1's not going to work. Oh, you wouldn't start with 1 because you've already done it out. But no, maybe. You can sometimes have 2 factors. So 1 makes 2 minus 5 minus 18 plus 45. So you can see that doesn't work. Minus 1 makes minus 2 minus 5 plus 18 plus 45. So minus 1 is not, x plus 1 is not a factor. Then if you go 2 to the 3 is 8. So you get 16 here. Minus 20 minus 36 plus 45. So you get plus 51 plus 61 minus 56. So it's not a factor. So I just want to make sure I got that right. I did. So plus x minus 2 is not a factor. X minus 2 is not a factor. Then you got to look at minus 2. So this becomes minus 8, so that becomes minus 16. This still becomes minus 20. This becomes plus 36 and plus 45. And right away you can say, nope, none of the 2's work. So right there, we've hit a stumbling block. There's no real way to, there's no clear factors here. I mean, there's maybe a 3, but there's nothing that's coming out of this one. You can try factor by grouping. X squared is 2x, oh, hang on, 2x minus 5. And what can come out of this? 3, yep, 6, no, let's try probably more than 3. 6x plus 15, 9. And at minus 9, I get 2x minus 5. Ah, thank you. So the next two factors are x squared minus 9. So they want you to practice your factor by grouping in this one. 2x minus 5, and I can see that's a difference of squares. So I've come up with all the factors of this one. X minus 1, x plus 3, x minus 3. So I could have gone on with 3's, and 2x minus 5. Had I gone on with 3's, I could have figured out that 3 or minus 3 is a factor, and then continued on. However, by grouping, I was able to discover that. So for this one, yes. Because they obviously don't want you to plug 5 over 2 into the equation. It just is chaos without a calculator. And then finally this last one. See if there's any patterns. No. And it's fairly complicated to the power of 4. So there's no grouping when there's 5 terms. So let's see if we can find 1. Let's use x minus 1 as a root, as a factor. So that's positive 1 as a root. I get 6 plus 1 minus 7, which is great so far. Minus 1 plus 1. Ooh, that made it easy, didn't it? So that means x1 as a root is a factor. So that means I can just take all those numbers and do synthetic division. So x minus 1 is a root, is a factor. Taking synthetic division, I can take 6, 1, minus 7, minus 1, plus 1, and I can figure out what cubic I'm left with when I do it this way, and then I just do it like this. So bring the 6 down. 6 times 1, 6. Add them, 7. 7 times 1, 7. Add them, I get 0. So there's not going to be an x. So 1 times 0 is 0. When I add them, minus 1. Minus 1 times minus 1, I get minus 1 when I add them, 0. So that means I'm talking about 6x cubed plus 7x squared minus 1 cubed and squared, and there's no x in there. So the next question is, can I figure out factors in here? For instance, is x plus 1 a factor? If I plug in minus 1 in here, I get minus 1 times 6 minus 6 plus 7 minus 1. Oh, I've discovered that x plus 1 is also a factor. So I'm going to do synthetic division again, but this time you have to account for one of your missing numbers. So I have plus 0x here. If I bring the numbers down for synthetic division, I'm left with 6, 7, 0, and minus 1. And this time my root I'm working with is minus 1. Bring it up a bit. And I do the same synthetic division. I'm left with 6. 6 times minus 1 is minus 6. When I add them, I get 1. Minus 1 times minus 1 is minus 1. And when I add them, I get minus 1. This times that is 1. So now I'm left with 6x squared. This is what I'm left with ultimately. I'm left with 6x squared plus x minus 1. So far so good. The big question is, can I factor the last one into anything that resembles 2x minus 5? And to do that, we're looking for something that multiplies out to minus 6 and adds up to plus 1. And indeed, we discover that it's plus 3 and minus 2. Now, because there's a 6 in front, remember this is squared, because there's a 6 in front, I'm going to do the slip and slide method this time, which means I take x minus 2 and x plus 3, and I divide them by 6, the number in front, minus 2, and I'll show you the slip and slide method over here. So I just take normal roots like I would, like this, but then I have to remember to divide each of those by 6 here and 6 here and see if they can simplify. Well, this can simplify to x minus a third, and this can simplify to x plus a half. And then I take this number here and put it in front of the x. So that means the actual roots, using the slip and slide method, are 3x minus 1 and 2x plus 1. And if I expand this, I get 6x squared plus 3x minus 2x minus 1. I do indeed get back to that. So that means I've successfully factored all of it. And are any of those the factors we're looking for? Nope, 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 nope. So for this last one, even though it was tough, it's a big old no. Great, let's continue. I'll have to stop and do part 2 because I just don't have time. These are fairly long, as you can see, because it's a lot of guesswork. Okay. So they essentially want you to look at the last number and say, okay, I got 24 at the last number. You should also always look to see if there's anything in common. I can take x squared out of here. I can only take a 2 out of both of these, but I don't think it's going to work by grouping. So I get x minus 3 here. And if I take minus 2 here, I get 5x minus 12. So factor by grouping did not work. So they want me to use the factor theorem anyway, which says that if x minus 1 is a factor, the root of 1, when I put it into here, will come out with a remainder of 0. So I get 1 minus 3 minus 10 plus 24. So x minus 1 is not a factor. And by the way, to figure out all the factors, you'd look at 24. So all the factors of 24 are plus minus 1, 2, 3, 4, 6, 8, 12, and 24. So those are all likely factors. So obviously I start with the plus and minus 1s first. So that's not a factor, so I go on to x plus 1, which says that if minus 1 into here comes out with 0, x plus 1 is a factor. So I get minus 1, minus 3, plus 10. And if you don't see what I'm doing, practice your math. Plus 24, no, that is not 0. So we're on to, so we can cross this off. And we're on to the plus and minus 2s. So we'll start with 2, plus 2. 8, minus 12, minus 20, plus 24. So 8 plus 24 is 32, minus 32, 0, which means x minus 2 is a factor. Now you can see how long this takes. So now I have to take using synthetic division, I take my 1, my minus 3, my minus 10, and plus 24. Make sure there's no missing x's. There's not. And I'm using my root of 2. And I'm bringing the numbers down. 1 times 2 is 2. Add these. I get minus 1 times 2 is minus 2. Add these. I get minus 12 times 2 is minus 24. And these, of course, cancel out. So that means my roots, my leftover binomial is x squared minus x minus 12, which obviously factors out squared, which obviously factors out to x minus 4, x plus 3. And my original one, x minus 2. And if you're ever in doubt, if you were to expand this, you should get this. Okay, should get that. You could do it kind of quickly in your head, but it'll kind of take a while to figure out a couple of them. Definitely if you multiply these last numbers, you're going to get plus 24. These first x's, you're going to get x cubed. It's just a question on the squares. Okay, so that means this is the answer for A. And these I will check in the book when we're done. Actually, let's just check for that one now. So I'll go to here, and I'll just copy these. Okay. And I'll go like that. And sure enough, did I get it? Right here? Yes, I did. Okay. So we should put those. I don't really have room to leave these here. Okay, on to the next one. So the factor theorem will say we have to look at the 4 times the 15, which is 60. So there's a whole bunch of possible factors for this. We always hope that 1 or 2 is one of them. The factors for this are plus or minus 1, 2, 3, 4, 5, geez, 6, 10, 12, 15, 20, and 30, and 16. There might be a couple more in the middle there. 8, no. I think I got them. Anyway, it's always easy to, obviously, to hope that some of these are the factors. So we're going to start with plus and minus 1. We'll start with plus 1. Plus 1's easy because you just do the coefficients. So that's 16 minus 1 minus 15. 16 minus 16, it's always nice when the first one we do is indeed a root. So we know that x minus 1 is a root. Now we just take our synthetic division, and you just got to make sure that none of the x's are missing. They're not. We're dealing with 4, 12, minus 1, and minus 15. And we're trying to use the root 1. And you just do it like this. So I bring my 4 down, multiply it by 1, put it here, add them together, I get 16. Multiply by 1, I get 16. Add them together, I get 15. And of course, these last ones cancel out. So I'm dealing with 4x squared plus 16x plus 15. Woo. You can see that that's going to be tough, because now you can either do synthetic division to see if, or factor theorem to see if another one is a root, like minus 1. Or you can do 4 times this is 60. Do we have one of our roots that adds up to 16? And I wish I'd kept my roots in there again. I think we do. I think it was 6 and 10. 6 and 10. And so I can do the slip and slide method, which just says I'm going to take my, pretend my roots are just like that. And then I'm going to take the 4 in front and divide and simplify. So this first one simplifies to x plus 3 over 2, which means I'm going to slide the 2 in front. So this first one is 2x plus 3. Go watch the videos on slip and slide. I think I've done a few. This one here simplifies to 5 over 2. If I slide the 2 in front, I'm left with 2x plus 5. And if you expand that, you should get your original thing. So 4x squared plus 10x plus 6x, 16x, yep, and plus 15. So there we go. We have figured out all the roots to this one. I might as well type it in. And this is going to be used when you're graphing and you're just getting better and better at graphing, essentially. It was minus 1. Okay, so that's good. That means for this B1 we have some roots. Oh, look at D. Jesus, that's just cruel. There's E there. Okay, so we're going onwards to the next one, which is this one. And we're using the same factor theorem. Again, we're looking at minus 48, but let's just start with 1, 2. So when I do 1, I get 1 plus 8 plus 4. Minus 48 clearly doesn't work. Minus 1 will still create plus 1 minus 8 plus 4.